Okay, once again, let me welcome all of you back from your spring break, and I hope you all had a pleasant and fun week, and you are glad to be back here. We do have a few more weeks to the end of the semester, and for those few more weeks, we have about 5 more chapters to cover, so we have a lot of work ahead of us. Okay, a couple of announcements. The homework assignment for our Chapter 20, end of Chapter 20 questions has been posted in Blackboard, and that is due on Sunday, March 23rd at 11 p.m. Also, I do have your exam number 2 with me, so you should stop me about 5 minutes to the end of class today, so I could give those back to you. And then the Chapter 20 lecture from last year has been posted in Blackboard and also in YouTube for the benefit of those of you who may want to take advantage of this. Okay, so for today we are going to start with Chapter 20. Chapter 20 is concerned with the chemistry of carboxylic acid and nitriles. Of course, we are going to discuss nomenclature, synthesis, and reactions of these classes of compounds. And then if we have some time at the end of this chapter, we should begin to do a review of spectroscopy. On this slide, I have a list of learning outcome objectives. You should use these items on this page as a study guide for preparing for the quizzes and the exam for the content of this chapter. So at this point, we want to ask ourselves, what are carboxylic acid and nitriles? Of course, carboxylic acid and nitriles, these are classes of compounds that most of you have already encountered during the course of this semester. So hopefully, most of everything we are going to do in this chapter should be sort of like a review to just about all of you here. With regard to carboxylic acid, you have a compound that is characterized by the presence of the carboxy group. This here is what we call the carboxy group. And the carboxy group does contain a carbonyl, which is a carbon-oxygen double bond, and an hydroxy group. Attached to the carbon-oxygen double bond is either an hydrogen atom or a carbon atom. Now, with regard to the nitrile, you have a carbon-nitrogen triple bond. This here, which we refer to as a cyano group. As you can see here, in the cyano group, the carbon atom is an sp hybridized carbon. This here is sp hybridized, and also the nitrogen atom is also sp hybridized. So at this point, let us look at some specific examples and then begin to discuss a nomenclature of these two classes of compounds. Let us start with the nomenclature of carboxylic acid. If you take a look at one of the simplest carboxylic acid, this molecule here, you find that the systematic name or the IUPAC name is derived from the name of the corresponding alkane. So in this particular instance here, the corresponding alkane will be ethane. So what do we do to derive the name of the carboxylic acid? We remove the E ending of the corresponding alkane name and we replace with the suffix OIC. So this is the suffix for carboxylic acid. In other words, that is the ending for carboxylic acid. So therefore, what will be the name of the IUPAC name for this molecule here? What is it? Ethanoic acid. Very good. That would be the IUPAC name. However, this is such a common carboxylic acid that we very often simply use the common name, which is acetic acid. So the common name acetic acid is an accepted IUPAC name. So subsequently, you just if you have this molecule here, just give the name as acetic acid. Now, if you take a look at this, what will be the name, the IUPAC name for this molecule here? What is it? A propanoic. Very good. Propanoic acid. Okay, if we have this here, okay, the IUPAC name will be butanoic acid. Okay, let us increase the complexity of this molecule now. Supposing we have this. Supposing we have this molecule here. In this case, you look for the longest carbon chain that contains the carboxyl group. The longest carbon chain that contains the carboxyl group. Let us look for that. Okay, I will say this will be 1, starting with the carboxyl carbon as carbon number 1. Of course, this will be 2. This is 3. Okay, this is 4. This is 5, and this is 6. Now, if you go this way, would that be the same? So it doesn't really matter at this point. Okay, very good. So therefore, the name of this compound will be, in this case, the alkyl chain, this here, will be a substituent. So this becomes 3 propyl, so that's a propyl group, and then the parent name will be, what will be the parent name? Hexanoic acid. Hexanoic acid. Supposing we have this. Okay, what is the longest carbon chain here? Okay, by the way, this is bromine. Okay, so we have the longest carbon chain. This would be 1, 2, 3, 4, 5, 6, 7, 8, and 9. In that case, this here becomes your substituent, and also the bromine becomes a substituent. Okay, so what would be the name of this molecule? What would be the name of this molecule? The substituent will also have to be in alphabetical order. Okay? The base name, of course, is what? The base name will be what? Nonanoic acid, okay? And then, of course, you have bromine in position number 2, so that becomes 2-bromo, 6-propenyl, okay? 6-propenyl, and then the nonanoic acid. This group here, okay, this is coming from propene. Now, if you recall, when we did alkene, to get the name of the fragment, you remove the E ending, and then you replace with YL. So that is why we got this here. That is why this becomes propenyl, okay? This group right here. Now, supposing you have this molecule here, the carboxyl group attached to a ring system. In this case, what you do, you give the complete name of the ring system, and then you add the word carboxylic acid. So this becomes cyclohexane, because this ring is cyclohexane, carboxylic, one word, carboxylic, and then the acid is separate. Cyclohexane carboxylic acid. Now, supposing you have this. Supposing you have this. Okay, once again, you give the complete name of the ring system. In this case, because you have another functional group in the ring, the carbon that is attached to the carboxyl group will be assigned position number 1. So this is position number 1. And then this carbon here, position number 2, number 3, number 4. Okay? So now this, yes. The carbon that is attached to the carboxyl group will be assigned position number 1. Huh? Which one is it? This is the carboxyl group. Huh? No, I said no. Whether, because you have a double bond here, whether you have a double bond or not, the carbon that is attached to the carboxyl group will be assigned position number 1, regardless of whatever you have in the ring system. Okay? Okay, so now this becomes 2-cyclohexene, because that would be the name of this, I'm sorry, cyclopentene. That would be the name of the ring system, and then you simply then add the word carboxylic acid. Now, if you take a look at this molecule, which many of you have seen before, if we go by that system, we would normally want to call this benzene carboxylic acid, right? However, this compound here is such a has been around for such a long time, and the common name is actually an accepted IUPAC name. So the common name for this is benzoic acid. So if you have to give the name of this compound, just use benzoic acid. That is an accepted IUPAC name. Now, supposing you have two carboxyl groups attached to in the same molecule. In this case, you number the carbon atom. Okay, this is 1, 2, 3, 4, and 5. So we are going to call this, give the name of the corresponding alkane. The name of the corresponding alkane will be what? What is it? A pentane, right? Okay. So that becomes pentane di, then use the suffix oic. So that becomes pentane dioic acid. Okay. In other words, you have two carboxyl groups in the molecule. Notice here, the carbon of the carboxyl group becomes part of the parent name, which we call the pentane. Okay, then you simply add the di and then the suffix oic acid. Of course, if you have branches, okay, if you have branches, you see, number the parent name in which the longest carbon chain has got to include both of the carboxyl groups. So now we have, okay, now you want to number from, if you 1, 2, 3, 1, 2, 3. So which side are we going to start numbering from? What do you think? The right, okay, very good. So this is the right. We start from here, and this is left. Okay, so we start from left. I'm from right. Why from that is correct? Why? because of alphabetical order, yes. Because the branch here, the ethyl, comes before methyl. Okay, so therefore, we start numbering from here. So this is 1, 2, 3, 4, 5, and 6. Okay, so this becomes 3 ethyl, 4 methyl, 1 dioric acid. Okay. Okay, so at this point, I'm going to leave the nomenclature of carboxylic acid to you. You do have some more examples in your textbook. So what I want to do now, let us take a look at the nomenclature of nitriles. The simplest nitrile is here. Just as in the case of the carboxylic acid, the name is also derived from the name of the corresponding alkane, the IUPAC name. So in this case, the corresponding alkane will be ethane, because you have 2 carbons here. So this becomes ethane. What you simply do, give the name of the corresponding alkane, ethane, and then you add the word nitrile. One word. Ethane nitrile. If we have this here, okay, this becomes, how many carbon here? 1, 2. Keep in mind, you have to count the carbon of the cyano group as one of the carbon atoms. So this becomes 1, 2, 3, 4, and 5. Okay, so this becomes pentane nitrile. Now, sometimes, particularly for some of the simple nitrile, you could derive the name from the corresponding carboxylic acid. For example, if we have this here, you know, this molecule here, we say this is acetic acid, right? We told you that this is an accepted IUPAC name for that molecule. Now the corresponding nitrile for this would be this here. It has 2 carbon atoms. Now to derive this name of this compound here, we simply replace the IC of the corresponding carboxylic acid with the suffix O nitrile. So therefore, this will become acetonitrile. That becomes acetonitrile. Also, another example, say if we have this here, yes. No, that is another way of, yes, you could call it ethane nitrile, but what I'm giving you here are two different ways of naming nitrile. Okay, particularly when if the carboxylic acid, corresponding carboxylic acid, is a fairly simple carboxylic acid. If you take a look at this molecule here, the corresponding carboxylic acid will be benzoic acid, this here. That is benzoic acid. So what you could do here, you remove the OIC, and replace with O-nitrile. So in that case, this becomes benzonitrile. This molecule here becomes benzonitrile. So the choice is yours. You could use any one of those methods for nomenclature, for naming these compounds. Now, when the cyano group is attached to a ring system, for example, if you have this, okay, in this case, what you do, you give the name, just as in the case of the carboxylic acid, you give the name of the ring system, in this case, is cyclohexane, then you add the word carbonitrile. Carbonitrile. So if we use that system, we could therefore call this here, remember the one I gave you earlier, as benzonitrile. We could call this benzene carbonitrile. But for this molecule here, the name that we generally use for this is benzonitrile. So I will use the benzonitrile. If you have this here, okay, if we have this, just as in the case of the carboxylic acid, you have the cyano group attached to a ring system. The carbon of the ring system that is attached to the cyano group will become carbon number 1. Okay, so this becomes carbon number 1. And therefore, you want to number the rest of the chain or the ring so that you give this double bond as low a number as possible. So we say 1, 2, 3, 4, 5, and 6. Okay, so this becomes because this double bond is in the 3 position, become 3 cyclohexene, the complete name for that ring system. Then you add the word carbonitrile. Okay. Okay, so that is all I want to do with regard to nomenclature of both the nitriles and carboxylic acid. You do have some more examples in your text. And also, yes, I did forget to tell you, I did post the PowerPoint material in Blackboard. So I have some more examples in the PowerPoint posting that is in your Blackboard. So you may want to take a look at that also. So at this point, let us start taking a look at the synthesis of carboxylic acid and nitriles. What I want to do, I want to start with the synthesis of the nitriles. You will find that we've done most of those before. Synthesis of okay, I think we have about 3 methods for making nitriles. The first one I will call SN2 reaction between a cyanide which is this here. We've seen this before several times. Between the cyanide and a substrate, and I'll call that an alkyl bromide or alkyl halide. Let's call it alkyl halide. The alkyl halide could be a bromide, chloride, or iodide. And this alkyl halide should be either primary alkyl halide or secondary alkyl halide. So let us qualify that. Primary or secondary. For example, if we have this here, and you take, generally we use sodium. The source of the cyanide will be either sodium cyanide or potassium cyanide. Take sodium cyanide or potassium cyanide, you have an SN2 reaction. Keep in mind, if you recall SN2 reaction, you have a nucleophile and then you have an alkyl substrate that has a good leaving group. In this case, the leaving group is bromine. This nucleophile comes here, attacks from the back, and the bromine will leave. So now we have this. Okay, close your sodium. Okay, so that is an example of an SN2 reaction. Another example we take this here, benzyl iodide, is a potassium cyanide or sodium cyanide in an SN2 reaction. Okay, so that is one method for making nitrile. Another SN2 reaction between the cyanide and an alkyl halide, which is either a primary alkyl halide or a secondary alkyl halide. In other words, we could also do this. Now, another method for making nitrile, let's call this 2 nucleophilic addition to carbonyl of aldehyde and ketones. Nucleophilic addition to carbonyl of aldehyde and ketones. Also, we have seen that before. If I take this ketone here, in this case, I take hydrogen cyanide. In this case, we use hydrogen cyanide, and you get this here. If you recall, we get what we call a cyanohydrin. Cyanohydrin simply means you have a cyano group and an hydroxy group within the same molecule. We could do the same reaction with an aldehyde. Think of hydrogen cyanide as consisting of the negatively charged cyanide and, of course, positively charged hydrogen. So you are going to get a nucleophilic addition. This goes here. Of course, electron goes here. You don't have to write the mechanism unless I ask you to do that. And then whatever you get, the proton will then come to this oxygen here. Okay, so that is method number 2. The third method for making nitrile is a dehydration This is a new reaction for you, so you have not seen this before. Dehydration of primary amide with thionyl chloride. So that is another function of thionyl chloride. A primary amide is any molecule in which you have the carbonyl attached to what we call an amino group. And that carbonate is also attached to either a carbon atom or an hydrogen atom. Now, if you take this, take thionyl chloride, what this is going to do is essentially remove a molecule of water from the amide. This is what we call an amide. This is an amide. Okay, you remove a molecule of water from here, these two hydrogen and this oxygen here. Okay, that is the net process of this reaction. And so you end up with this here. Plus okay, you don't have to worry about the hydrogen chloride and sulfur dioxide. Our concern is this nitrile here. Okay, so if you don't write this here, that is fine. Okay, so let us give you a couple of specific examples on this. I could take this primary amide here, react with thionyl chloride, in this case I get the cyclopentane carbonitrile. Or we could take this, this amide, thionyl chloride. Here I get the butane nitrile. And this is cyclopentane nitrile, one word. Okay, so I have given you three methods for making nitriles. Now let us now take a look at the carboxylic acid, synthesis of carboxylic acid. I'm going to turn the okay, I'm going to make this easy for you, so I will number them. Okay, 1. Hydrolysis of nitriles. Now I've just shown you how to make nitriles, so now we want to convert the nitriles to carboxylic acid. Take this. I believe we have done this several times before. And you take dilute acid. The dilute acid will hydrolyze this nitrile to carboxylic acid. Now, supposing you have this type of nitrile, Okay, this type of nitride, of course, this is a cyanohydrin that is coming from cyclohexanone, right? Okay. If you want to hydrolyze this, here, because of this hydroxy group, in the presence of a carboxylic, of a dilute acid, what you want to do here is to hydrolyze this in basic medium, do the hydrolysis in basic medium. Because if you do not do the hydrolysis in basic medium, you are going to dehydrate this molecule here. It will lose water, and you don't want that to happen. Right? So what you do your hydrolysis under basic condition, and then when you do that, you get this. Because you are doing this under basic condition. And then very slightly acidify, because generally when you do this, you are applying a heat, and very slightly acidify this to get your desired carboxylic acid. Now you see what we've done here. If all I did was take this, if I just did this, if I use this here, what is going to happen, I will also dehydrate this here. So you end up getting this. And that's not what you want because of the acid. And because of that, that is why in this particular instance, therefore, if you have a situation like that, all you have to do is simply do, let us say we have this here. Okay, so all you have to do at this point, because of the hydroxy group that is here, you just have to do this. Step 1, hydrolysis under basic condition, and then step 2, okay, so you don't have to write it this way, okay, just write step 1, step 2, and then that gives you the desired product. Okay. Yes. Yes. Generally, whenever you have an hydroxy group within the same molecule, not just for cyanohydrin, because keep in mind that hydroxy group in the presence of dilute acid, you lose water, so you don't want to do that. So that's why you go through the basic hydrolysis, then gently acidify the solution. Okay. Okay, so that is one method of making carboxylic acid. Okay, number 2, oxidation of primary alcohols. I think all of you already know that. If you take a primary alcohol and you take chromium trioxide in acid, get your carboxylic acid. Okay, I think we've done some examples of this in the past. Okay, so number 3, oxidation of aldehydes. So there are many ways in which you could oxidize aldehydes to give carboxylic acid. If we use this specific example here, of course, we could use the same chromium trioxide in acid you could also use silver oxide in ammonium hydroxide. If you recall the silver mirror test which we gave you earlier, okay, that will give you this here. To give you the carboxylate. And then when you add the dilute acid to it, get your carboxylic acid. Now we could also obtain carboxylic acid as a result of carboxylation of Grignard reagent. So this is 4, right? Carboxylation of Grignard reagent. We all know what Grignard reagent is. If we have any Grignard reagent, let us say we take this. And we add carbon dioxide. Step 1, and then step 2, dilute acid. You get this here. Okay, what happens here, keep in mind, the acid group in the Grignard reagent acts as a nucleophile. If we want to give you the mechanism for this. And you have your carbon dioxide, which is dry ice. The Grignard comes in here. It's a different color pen. How many of you are taking the organic lab now? Have you done Grignard yet? Okay, you are going to do Grignard reaction, okay? The problem with Grignard is it reacts with everything. So you have to be very careful. If you are not careful enough, your reaction will not go. Because it reacts with air, it reacts with carbon dioxide, it reacts with water, and all of those things are present in the air. So when you do your reaction in the lab, the first thing you want to ensure is to make sure there is no air in your flask. Because if you have any kind of air in your flask, it will not work. Okay? So what you do, I think you have to make sure that you have heater in there first, the ether vapor will drive out the air, and before you dumping your magnesium to make your Grignard reagent. So anyway, that is a very interesting reaction. Okay, so you have this. Okay, so you have that right here. And then once you form this carboxylate here, at this point, this is where you now add the dilute acid. You have to make sure that the reaction has finished completely before you add your dilute acid. If you don't do that, yeah, there will be no reaction, okay? Okay, so now you have, you simply now grab the proton here, and that will be the mechanism of the Grignard reaction with okay. Now the particular reaction you guys are going to do in your lab will be this here. I believe you are going to start with bromo. You start with bromobenzene, then you have magnesium, in ether, and then you have your Grignard. Once your Grignard starts, once you finish making your Grignard, okay, which is this here, then you're going to add your, I believe you guys are probably going to use either a ketone or an ester, you know. Okay, I believe, let me see, I don't know whether, either ketone or ester. So once you form this Grignard here, and then you are going to add whatever you need to add. I believe it is this here, this ketone here. Okay, this ketone is called benzophenone. I think this is the ketone you guys are going to use, but don't quote me on that. Okay, then step 2, you have to make sure that this Grignard reacts completely with this ketone before you add your dilute acid. Because if you don't do that, the Grignard will react with the dilute acid and there will be no further reaction. Okay? So therefore you form this. Okay, that is just, okay, of course this is not making carboxylic acid. I just want to let you guys know, since we are talking about Grignard now. So in your case, you will make this tertiary alcohol, okay? But anyway, a Grignard reagent, if you want to use this Grignard reagent here, once you form this, since we want to make carboxylic acid, you dump in some dry ice, carbon dioxide, step 1, and then step 2. In this case, you are going to get benzoic acid. Okay, was that number 4 or number 5? Number 4, okay. Is it time? Oh, okay. Huh? Oh, scroll down. Okay, well, we will continue from here. I think our time is past almost 7:30 now. So I want to give you back your exam. Okay, so when we come back, we are going to continue with chapter 20. Is it going to be free? Yeah, that's what I'm trying to ask you now. You guys want a quiz on Thursday? Okay. Okay. Okay, since you just came back from our spring break, I'll let you go on that. So we will have the quiz on next Tuesday. So anyway, on Thursday we are going to continue with chapter. Okay, so I see you. Let me give you back your exam.